Dear students of class 10, today I am going to discuss lens formula, its magnification and numerical problem to use lens formula and magnification formula. So first of all, sign conventions and assumptions used in lenses. Sign conventions and assumptions used in lenses are just similar to those used for spherical mirrors. So the first sign convention is all the distances are measured from the optical center of the lens, that is this point C. Distances in the same direction as that of light are taken as positive and opposite to light are taken as negative. Heights upward are taken as positive and heights downward are taken as negative. So these are three sign conventions. So according to these sign conventions, for an object placed on left hand side of the lens and rays traveling from left to right, u, that is distance of object from the optical center of the lens, is always negative. V is positive if image is formed on right side and V is negative if image is formed on the left side. Focal length and radius of curvature of convex lens will be positive and focal length and radius of curvature of concave lens will be negative. So these are some sign conventions and assumptions. Assumptions are, number one, lens is thin, so that distances are measured from the outer edge of the lens instead of inner point, that is optical center. Second, aperture of the lens is small. In other words, rays make small angles with the principal axis. Or you can say the rays entering the lens are nearly parallel because the aperture is small. Then we come to lens formula. So lens formula is the relation between object distance, image distance and focal length of the lens, and is given by 1 upon f is equal to 1 upon v minus 1 upon u. This is known as lens formula. And when we have to apply this lens formula, proper sign conventions are to be applied. Then magnification. Now, magnification of a lens is defined as the ratio of size of image to the size of object and is given by m is equal to I upon O is equal to v upon u, where v is the distance of the image from the lens, u is the distance of the object from the lens. So it means this magnification gives the magnification of the size of the image, how much lens can magnify an object. Then we have to solve a numerical problem. So a concave lens of focal length 15 centimeter, so f is equal to minus 15 centimeter. At what distance should an object be placed to form an image at 10 centimeter from the lens? It means we have to find u, distance of object from the lens. So that image formed is at 10 centimeter. It means v is equal to minus 10 centimeter in case of concave lens. So using lens formula, 1 upon f is equal to 1 upon v minus 1 upon u. We have 1 upon u is equal to 1 upon v minus 1 upon f, or 1 upon v minus 10 minus 1 upon f minus 15. Simplifying it, 1 upon u is equal to 1 upon 15 minus 1 upon 10, or if you simplify it further, it is equal to 2 minus 3 upon 30. It comes out to minus 1 by 30, or u comes out to be minus 30 centimeter. It means if image is formed at distance of minus 10 centimeter from the lens, object must be placed at a distance of minus 30 centimeter from the lens. And if we calculate magnification, m is equal to v upon u, minus 10 upon minus 30, it is 1 by 3, or it comes out to be m is equal to plus 0.33. That is, size of image is 1/3 of the size of the object. So image is smaller in size. And it proves that if m is positive, image formed is erect and virtual, because in case of concave lens, image formed is always erect and virtual. Then we define a power of a lens. So power of a lens, when focal length of lens is small, say focal length of convex lens is small, so we have a convex lens of shorter focal length, then it will converge the rays very close to the optical center. And if focal length is large, it will convert the rays far away from the optical center. It is power of a lens is inversely proportional to focal length of the lens, and it is defined as the reciprocal of the focal length of the lens. In other words, power measures the degree of convergence or divergence of a lens. So P is equal to 1 upon F. If F is equal to 1 meter, P is equal to 1 D. So it is called 1 diopter. So diopter is the unit of power in SI system. So power of a lens is said to be 1 diopter if its focal length is 1 meter. So power of convex lens will be positive and power of concave lens will be negative, because focal length of convex lens is positive, concave lens is negative. So this unit is used by doctors to examine our eyes and to correct our sight using lenses of different powers. So this is all about lens formula and magnification. So stay tuned, be happy, and if you like my videos, kindly subscribe my channel and share it with your friends and classmates. Also, I request all the science teachers to share my channel with your friends and teachers, colleagues, or your students. Thank you.